let's write this stuff down. Okay, so whenever we are going to need the chain rule is whenever we're dealing with composite functions. Composite functions are whenever you have like f of g of x. You have like a function inside of a function. So, I don't know if your families are like mine, but anybody have like the aunt or uncle or cousin or somebody that likes to wrap your Christmas presents or birthday presents, and like, anybody ever got a present? It's like you got a box inside of a box inside of a box, right? And then the middle box is like covered in zip ties and duct tape or something, and it takes you 20 minutes to open your present. My brother likes to do things like that. But you can think about that a little bit like this when we're doing chain rule, okay? So whenever we're doing chain rule, what's going to happen is we've got to take the derivative of the outside, and then the derivative of the inside, and then there could be another inside, depending on how many iterations of this function you have. Typically, you're not going to have to use like the chain rule more than twice, because then it gets really complicated if that's the case. The ones we're going to start with today are going to be mostly just one time that you got to use the chain rule. So the rule is that if you're taking the derivative of f of g of x, you're going to take the derivative of f, the outside function, first, but then the inside stuff stays the same. It's just g of x. But then you must multiply it by the derivative of whatever the inside stuff is. Okay? So our first example is going to be f of x equals the square root of 2x minus 3. And so that free response that I gave you yesterday, I think the equation's like square root of 6x minus 1 or something like that for the number 6 free response assignment. You're going to need chain rule for that. It's like this. So if you did it yesterday, you probably did not do it right, I would say. So let's do this. I do want to write this before we take the derivative. And square roots are a little hard to deal with derivatives. So instead of using a square root, I'm going to write it like this: 2x minus 3 to the 1/2 power. And so what we need to do is we need to identify what our outside function is and what the inside part is. So for this particular case, when we look on the outside, we're looking at something being raised to the 1/2 power. And then our function on the inside is this 2x minus 3. Okay, so when we take the derivative of this, we are going to work on taking the derivative of the outside part first. So it's like, you know, your Christmas present. If you want to get the stuff on the inside, you got to open the outside box first. So I'm going to take the 1/2. I'm going to leave all the stuff on the inside the same. I'm not taking the derivative of it yet. That's the inside box. It's still there. It's still wrapped. You can't do anything with it until you get the outside box done. And then I'm going to do this to the negative 1/2 power. So you can see there, I took the derivative and just treated basically like that green box, like it was my variable, even though it's more than a variable. All right. So that takes care of the derivative of that outside, that x to the 1/2 power. But with chain rule, we must multiply this by the derivative of the inside. Thankfully, our inside function, 2x minus 3, is pretty simple, right? 2x minus 3, what's its derivative? 2. Okay? So then from here, if it's free response, technically you can leave it right here. I was interested on the free response portion of the midterm to see what you guys did when you had to take that derivative with a chain rule on that first question. Some of you just took the derivative and stopped and left it messy and then used that. Some of you simplified it, and I think I had mistakes like both ways, like you didn't simplify it and that caused you to make a mistake later, or you did simplify it and you made a mistake which caused you to miss something there. But so free response, you could stop here, but a lot of times there's a benefit to simplifying it also. Hallie also saved herself because she messed up simplifying, but put a box around the original, so I graded that as her answer. And then she used the original in Part C instead of going back to her simplified version. So even though it was wrong, I'm pretty sure that would not count against you on the AP exam, I think. Because she got that one completely. So when we're putting all of this together right here, this is 1/2 times 2x minus 3 to the negative 1/2 times 2. What could I put together that would make this a little easier to deal with? 2 and the 1/2. What's 2 times 1/2? 1. It just kind of goes away, right? Because it's 1. So I could just write this basically as 1 over the square root of 2x minus 3. And if you have to do anything with this, if you got to like plug a number into it or write an equation of tangent line, something, this is easier to deal with. Plus on multiple choice, that's what it's going to look like. We'll leave it like this up here. Okay, questions there for the first one? All right, here's your second one. All right, so for this one, it should say find dy dx. So it's asking for the derivative of y equals sine of 8x. So what is our outside function here? The sine. What is our inside function? It's just that 8x. So it's a very simple inside function, right? But it does have an inside function, so we have to deal with that. So when we take the derivative here, the derivative of y, I'm going to call it dy dx. You could call it y prime, but they told us to find dy dx, so I'm going to call it dy dx. All right, we got to take the derivative of the outside first. What's the derivative of sine? It's cosine. So this is going to change to cosine. And then it's cosine of what? 8x. Do not take the derivative of the stuff on the inside. It stays the same. You don't take the derivative of it until you're multiplying over here on the side, right? So we're just taking the derivative of sine. It is cosine. We leave the other stuff the same. Then we multiply by the derivative of the inside. What is the derivative of the inside here? 8. So you would probably clean this up a little bit and write it like this: 8 cosine of 8x. Okay. Questions? All right. Let's try this next one. All right, now, example 3, we already know how to take the derivative of that. What could we use before we knew chain rule? We could use quotient rule. So I want to do this both ways so you can see the difference, and then we'll try to convince you that that chain rule is better on this one. But if I do this with quotient rule, then f prime of x, and I should say find the derivative here, I didn't, would be low d high. What's the derivative of the top? What? 0. Right? This is where students usually mess up on this. They say it's 1 but it's 0. Minus high d low. So what's the derivative of the bottom? 1 over low squared. So this stuff times 0 just basically goes away because you're multiplying it by 0. Actually, I might not be able to convince you on this one. This one's not that hard. Negative 1 over x plus 1 squared. So quotient rule will work. So you don't want to throw it out. If you prefer it, you can do that. If I want to do chain rule instead for this one, though. Okay. 1 over x plus 1, could I write it this way? X plus 1 to the negative 1. Would that be okay? That would be a possibility, right? Those are equivalent to each other. So if I want to use chain rule, I'll have f prime of x. So chain rule, my outside function is this stuff being raised to the negative 1 power. The inside function is the x plus 1. So when I take the derivative here, it will be negative 1 times x plus 1 to the negative 2 power. And then that's just the derivative of the outside stuff. I've still got this x. Oops, let me mark that out. I still have this x plus 1 on the inside. So I have to multiply it by the derivative of the inside. But what's the derivative of the inside? It's just 1. So if I rewrite this, I have negative 1 over x plus 1 squared, which is the same thing I got with quotient rule. I might not be able to convince you here that chain rule is better, but I think there's another one I'm going to try to convince you of this on, because quotient rule is not all that difficult on this one. But I like chain rule better still. I'll be honest. Now that we know chain rule, you never have to do quotient rule again if you don't want to. I never did quotient rule whenever I was in high school. I don't really know why I did that, because quotient rule is a little bit easier to me now than what I used to do. But you don't ever have to do quotient rule again if you don't want to, because chain rule can take care of it. I'll show you what I mean in a little bit. All right, so example 4. We've got f of x equals 2x minus 5 to the 5th power. So my outside function is the stuff being raised to the 5th power. My inside function is the 2x minus 5. Now this problem we could do before we learn chain rule, but to do it we would have to expand 2x minus 5 to the 5th power, which would be difficult, right? Because you could use Pascal's triangle, but it's still not an easy Pascal's triangle because you got that 2 and that negative 5. So you would have to expand it first, then take the derivative. And here's the problem with that. Usually these are multiple choice, and usually the answer choice is not expanded. It's like condensed back down. So it would be really difficult to get the multiple choice question right doing it that way. So, so if we're taking our derivative here, we take the derivative of the outside part first. So that would be 5 times, leave the inside stuff the same, 2x minus 5, to the 4th power, right? So basically you're just pretending like that 2x minus 5 stuff right there is just a variable, right? And you're just using your power rule for that. But then this is a little different because you got to multiply by the derivative of the inside. What is the derivative of the inside here? 2. Right? And so all of this is multiplied together, so you could multiply that 5 and that 2 together to clean it up a little bit and get 10 times 2x minus 5 to the 4th. I am not going to do this problem the other way because you would have to expand 2x minus 5 to the 5th out. You would have to take the derivative of that, which is going to give you like something x to the 4th, the big long polynomial. Then you would have to factor that back to 2x minus 5 to the 4th power to finally get your answer, which would be very lengthy and difficult to do correctly. So chain rule definitely makes this a lot easier than it was before. Yes? That is taking the derivative is what we're doing. So we're multiplying out front by that exponent and then decreasing the exponent by 1. So it's like the power rule. It's like you're taking the derivative of x to the 5th, which would be 5x to the 4th. But instead of having this x right here, we have the 2x minus 5. Yeah. So that's what's happening there. Okay? All right. Let's look at a couple more. Maybe more than a couple more. How far we? No, we got 4 more. I'm gonna save natural logs and exponentials for tomorrow. All right. So, for example 5, we have y equals 2x minus 3 tangent x squared. So, for our 2x, do we need anything special for that? We just take the derivative of it like normal, right? I've got 3 tangent x squared. What do I need for this? What's my... I'm going to need a chain rule. What's my outside function? That tangent right there. And then the inside is this x squared. The 3 is just a coefficient, so it's just going to kind of hang out front, right? So, so when I take the derivative of this, I think I'll call it y prime this time, or you can call it dy dx. Either one's fine. Derivative of 2x, just 2. Then this 3 is going to hang out front. What's the derivative of tangent? Secant squared of, leave this stuff alone, x squared, right? That stays the same. We're treating it like it's a variable at first. But then what do I have to do after I've taken the derivative of that outside function? I've got to multiply it by the derivative of the inside function. What is my derivative of x squared? 2x. When Hunter was like 5, I taught him that the derivative of x squared was 2x, so that like I could ask him that question, and then like kids at school would think he was super smart, even though he didn't know what it was. He just memorized it. And one day, my mother-in-law was fussing at him for not paying attention in Sunday school like his cousin Maddie was, and she said, "Look at Maddie. Maddie is being so smart." He said, "Well, does Maddie know what the derivative of x squared is?" So, he thought he was pretty smart knowing that too. Okay, so combining stuff here, all of this stuff is multiplied together. So this 3 right here and this 2x, we can multiply that together. So we could make this 6x secant squared x squared. There's not really much else you can do with that. Just leave it. Okay, example 6. There's a couple ways you can deal with this. One of them is easier than the other. So one possibility, if we would choose to do it, is that your outside function would be the cube root. Then you would have this function on the inside, and then on the inside of that, you would have another function, right? So it would be a triple chain rule. So you would have to do the derivative of that root, then the derivative of the something squared, then the derivative of the x squared minus 1. And you'd have like a string of those things multiplied together. However, there's a way around this, because the cube root of x squared minus 1 to the second, how could I rewrite that? I could make it x squared minus 1 to the 2/3. And that's going to help you avoid having to do the triple chain rule. Sometimes you do actually have to do the triple chain rule, and you can't get away from it. But in this case, you don't. So, right here, and then our inside is this x squared minus 1. Okay, so if we take the derivative of this, derivative of the outside part first, so that's going to be 2/3 x squared minus 1, and we're going to subtract 1 from 2/3. What's that going to give me? Negative 1/3. This stuff right here stays the same, right? We left that alone. But that's our inside part, so we got to take the derivative of x squared minus 1, and that would be 2x. Now, when you're simplifying this, especially when you got this fraction, remember this is all multiplied together. It might be a good idea to like put this over 1 and this over 1 to kind of help you keep everything straight. So, right here, I've got this negative 1/3 power, so I can move this stuff down to the bottom there. And so, in the top, I've got the 2 and the 2x remain, so that gives me 4x in the numerator. In the bottom, I already had a 3, and then I'm moving this down to the bottom, so I've got x squared minus 1 to the positive 1/3 power. And they might leave it like this, or they may change it to a cube root like that. Okay, questions? All right. Okay, we got a couple more. Okay, so example 7, we could not do example 7 before unless we expanded 3x minus 4 squared. We could have done it if we expanded 3x minus 4 squared. It can be done with the quotient rule. However, if we try to do this with the quotient rule, it's going to be more complicated than it needs to be. You can write it down if you want. I'm going to show you like the beginnings of the quotient rule. I'm not going to simplify it because it gets kind of ugly. So you can just watch if you want, because chain rule is a better way to do this one. I think I can convince you of that this time. So, quotient rule, g prime of x would be low, 3x minus 4 squared, times the derivative of the high, which is just 0, minus high, derivative of the low. What have I got to use to take the derivative of the low? I've got to use, if I'm doing this, I've got to use chain rule to take the derivative of that bottom part, right? Because it's 3x minus 4 squared. So I would have to use a chain rule here. I'd have 2 times 3x minus 4 to the first power. But then I got to multiply by the derivative of the inside, which is 3. Over 3x minus 4 squared. And then you would have to simplify all of that, which can be done, but it's a little difficult. Or the better way, so I would do it this way. So let's do it chain rule. Chain rule is much easier to simplify. So instead of writing this as negative 5 over 3x minus 4 squared, let's write it like this. Negative 5 times 3x minus 4 to the negative 2. We can do that, right? It's equivalent. And so now we've got this outside function right here, the negative 5 times something to the negative 2 power. And then we just got the inside function of 3x minus 4. So you would just use the chain rule for this. So negative 2 times negative 5 gives us 10. We'll have 3x minus 4 to the negative 1. I'm sorry, not negative 1 power. What should that be? Negative 3. I'm subtracting 1 there. And then I multiply it by the derivative of 3x minus 4, which is 3. And so I could combine the 10 and the 3. That'd give me 30 3x minus 4 to the negative 3. And I could write it back as a fraction if I wanted 30 over 3x minus 4 to the third power. You can see this eventually is going to be 30 over 3x minus 4 to the third. It's going to take a little bit of work to get there, right? Do you guys agree that it looks like chain rule is probably a little easier on this? So, okay, now 8 is when things start to get fun. What are we going to have to do for 8? Okay, let's do that first. Yeah, roots are hard to deal with when we're doing derivatives. So let's make this x squared times 1 minus x squared to the 1/2. I like that better. All right, so what have I got to do now? I've got to do product rule. But it's going to be a product rule with a chain rule, right? It's going to include a chain rule. Because I've got two things. So this is not like simply an outside and inside function situation, right? I've got, like, over here, I've got an outside and an inside function situation. But this stuff is multiplied by this x squared. So we have got to use product rule, and within that product rule, we're going to have a chain rule included. So whenever we do this, product rule tells me I'm going to do f, which will be x squared, times the derivative of g. So that's my red box right here, right? So if I'm taking the derivative of this, I'm going to have 1/2 1 minus x squared to the negative 1/2. So that took the derivative of that red box, the outside function. But I still have the derivative of the inside function. And what is that derivative of 1 minus x squared? Not 2x. Negative 2x. Okay, so what I have found here, this was my f of x. I really shouldn't call this f of x, but I'm going to. This stuff right here, this, oh wait, no. All of this stuff right here is my g prime of x. I'm not done because I still got to do g of x times f prime of x, right? So I've got to do plus g of x, which is what's in that red box there, 1 minus x squared to the 1/2 power, times the derivative of x squared, which is 2x. So this part right here, let me label it. This was my g of x. And this part right here was my f prime of x. Whew. Simplifying this one's going to be fun, right? So, you know, technically for response you could stop here, but usually they're either going to want you to use it later, which means it's going to be beneficial to simplify, or it's going to be a multiple choice, which means you got to simplify. So we need to simplify here. So I've got, remember, all of this stuff right here is multiplied together. So I got x squared, a 1/2, a negative 2x. I can put that stuff together. So that is going, the 1/2 and the negative 2 gives me negative 1. And I've got 2 x's here and 1 here, so it's going to be negative x to the third over, I'm going to take this 1 minus x squared to the negative 1/2, I'll move it to the bottom, 1 minus x squared to the positive 1/2. And then over here, I'm just going to write it 2x, 1 minus x squared to the 1/2. Okay, let me stop for a second. What questions do you guys have? They will probably convert roots. They will probably also get common denominators here. So let's write that with roots. So negative x cubed over the square root of 1 minus x squared plus 2x times the square root of 1 minus x squared. So I'm going to put this over 1 right here because right now it does not have a denominator, so its denominator is 1. They usually are going to get common denominators here. So if they do that, then that means we would need to multiply this by square root of 1 minus x squared on top and bottom. Alright, so that's going to give us negative x to the third plus, what do I get when I multiply 2x squared of 1 minus x squared times square root of 1 minus x squared? 2x times 1 minus x squared. Right? When I multiply those two roots together that have the same thing underneath them, I'm just going to get that those roots are just going to cancel. And this is all over the square root of 1 minus x squared. And so I can distribute here negative x to the third plus 2x minus 2x to the third all over the square root of 1 minus x squared. And so that is going to give me, they'll probably write it this way, 2x minus 3x cubed over the square root of 1 minus x squared. And so that would be my answer. Okay, questions? These can get tricky, and we haven't even gotten the trickiest of tricky problems because we have not done a quotient rule with a chain inside, which we'll see, but we're not doing yet. So they can get tricky. We are not going to do natural logs and exponentials today, and so let me look at the assignment here and see what adjustments I need to make. Let's see. All right. Yes. Yeah, just paper clip them together there and you can set them right here. Should I? Let's see. I guess I'll let you do odds. 7 through 25. Odd. There. Let me make you do number 26 too. So 7 through 25 odd and number 26. So 7 through 25 odd and number 26. Fix that on canvas.